worksheet that we did today. Okay, so the original graph was -4 over x squared minus 3x. And the first thing you should do on every single one of these is factor. So factor the numerator and factor the denominator. The next thing, once it's factored, you can decide whether or not there's a hole. And in this case, there's not going to be a hole on this graph. A hole is going to exist when one of these denominator factors, x and x minus 3, if they had a matching factor up top, and then we could effectively cancel those, that's going to cause a hole. And again, we'll see that in a future one, but there's no hole here. I then am going to proceed to do the horizontal or the vertical asymptotes. Vertical asymptotes, there's two of them. Because vertical asymptotes occur when you divide by something really, really close to 0. So if we let x get really close to 0 or 3, it's going to cause the denominator to equal 0. When the denominator is equal to 0, those are our domain restrictions, which are also, in this case, our vertical asymptotes. So we have asymptotes at 0 and 3, x equals 0 and x equals 3. And then I'm going to find the horizontal asymptote, in which in this case the bottom is bigger, right? This is a 4 over an x squared. So we get y equals 0 as a horizontal asymptote. I can plot those with dashed lines. In all these questions, the function is in blue and the asymptotes are going to be in red. So I found vertical asymptotes, horizontal asymptotes, and now I'm going to find the x and y intercepts. Okay, the x-intercepts occur when y is equal to 0. But if you look at this function, if you look at the numerator is just 4. It's never 0. So that means y is never going to equal 0, which means, well, there's not going to be a x-intercept. Now what about a y-intercept? The y-intercept occurs when x equals 0. So if I plug in 0 for x, you're like, oh, nope, can't do that. X equals 0 was already a vertical asymptote, which also means it's a domain restriction. So we're not going to have any x-intercepts or y-intercepts. And so if I want to know the general shape of it, then I just plot some points. So I took my asymptotes and I went 1 to the right, 1 to the left, 1 to the right, and 1 to the left of my asymptotes, and I got these 4 green points. And I just had Desmos graph these green points for me, and then I can know, I go, rump, and I U in the middle, and then I rump over here. So I have 2 vertical asymptotes, 1 horizontal asymptote, no holes, and no x or y intercept, and then I can just draw a nice smooth curve. Again, I'm going to do the same steps on every one of these. I'm going to take the function, and I'm going to factor the numerator and denominator. I'm going to decide whether there's a hole. I'm going to find one or more vertical asymptotes by looking when the denominator is 0. I then am going to look whether the top wins, the bottom wins, or it's tied. In this case, the bottom wins, so I know my horizontal asymptote is y equals 0. I then am going to let x equals 0 to find the y-intercept, and y is equal to 0, which means the numerator is equal to 0 to find the x-intercepts. And then I'm going to plot a couple random points to give me an idea of what the general shape of the graph is. But this is what this first one should look like. Okay, all right, let's click this next one. All right, so here's the original function given to you. And like I said, first thing you're going to do is factor, and I factored a -2. So I factored, and you decide that there's no shared factor top and bottom. So there's no hole. The next I'm going to look at when the denominator is equal to 0, which is my vertical asymptote. So I know when x equals -3, that equation gives me a vertical asymptote. I then am going to look at the end behavior, and I see they're tied. This is an x, and this is an x. And so I look at the ratio. The ratio of 1 over -2 is -1/2. So that's my horizontal asymptote. I then am going to see when y is equal to 0. Well, y is equal to 0 when the numerator is equal to 0. So I figure out when that's equal to 0, which is -4. So I have this as my x-intercept. And then I find my y-intercept, and I plug in 0 for x. And when I plug in 0 for x, I basically just get 4 over -6, which is -2/3. I put a dashed vertical line at -3, a horizontal line at y equals -1/2. So I have my vertical and my horizontal. And then if I just plot my two x-intercept and y-intercept, I get these green points. And then I can just draw nice smooth curves because I already know that's where it has to go through. It can't go anywhere else. It has to go through those points, and I know the general shape of this. And hopefully you can understand that these are kind of flip-flop from normal because of this minus here. This minus right here is what actually did the change the blue from being kind of in the first and third. Instead, now it's kind of more in the second quadrant and kind of more in the fourth quadrant. Okay, so that's that second one. Third one. Okay, so this was the original function. This is like a 3x squared. And again, first thing you want to do is factor the numerator and denominator. So I factored a 3x out of the top, and then I double bubbled the bottom. I want to see if there's a hole. There's not. There's no common factor. X minus 4, x minus 3, x plus 1. I can't cancel anything, so there's no hole. Okay, next I'm going to find vertical asymptotes. Vertical asymptotes are when the denominator is equal to 0, the denominator equals 0 at x equals 3, and x equals negative 1. So I get my two vertical asymptotes. So draw your dotted lines at the vertical. And then I look at the original function and like, oh, I have an x squared over an x squared. And since they tie, I look at the ratio, so 3 over 1. So y equals to 3 is the horizontal asymptote. So draw that line. Then I'm going to find x-intercepts. X-intercepts are when y is equal to 0. So I'm looking for when that's equal to 0, that's equal to 0, when x is 0, and when x is 4. So I have these two guys, this one here, and here are my x-intercepts. And then I want to find, well, a y-intercept. We're like, well, if 0, 0 is an x-intercept, then it's also a y-intercept. And then I want to plot a couple more points to give me an idea. So I went ahead and went one to the left of this asymptote and plotted the point. I don't know why that won't stay there. Oh, yeah, I don't know why. It's 7.2. I have that there. Not sure why it's not actually letting me click on it. And then I plotted that point right there, which is 2, 4. Okay, so I plotted those 2 points, and then I went, and then it S's through here, and it U's over here, or I guess it asymptotically approaches it over here. And again, don't worry that the graph went through the horizontal asymptote. That is perfectly normal and okay. Horizontal asymptotes are what happens when it's the y value it approaches when x gets really big this way and really big that way. So when you scroll way out, you're like, oh, it approaches and it approaches. It has nothing to do with what's happening in here. So you can cross horizontal asymptotes. So you don't even have to have the same asymptote on the right and the left. As we get more advanced, you can see things like that. Okay, but again, same order that I do every single time. Factor top and bottom, decide if there's a hole, vertical asymptotes when the denominator is equal to 0, horizontal asymptotes, either top wins, bottom wins, or tied. Find the x-intercept by setting y equal to 0, which means the numerator equal to 0. Find the y-intercept by letting x equal 0, by just plugging in x equals 0. And then plot a couple random points. And again, I just plug in 2. Just plug in 2 here, 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 and here, and then figure out what this is, and you're going to get 4. And then you can come over here and plot the point 2, 4 to confirm that kind of S's through that center. All right, fourth one. Same process. Here's the original function. I'm going to factor. I'm going to factor the top and the bottom. I'm going to realize that there's no common factor top and bottom, so there's no hole. The vertical asymptote is x equals 2, so draw that. Then I'm going to find the horizontal asymptote, and you're like, ooh, wait a second. The horizontal asymptote, this is an x squared over an x. So if the top wins, there is no horizontal asymptote. And so what you end up with a slant asymptote, which means you have this line, and that's what the function's going to approach as x gets really, really, really big. You do have to use long division or synthetic division to actually do this division. This one is harder than I will put on the test because of this whole -4 thing. I promised on the test I'll make it like x minus 2 or x plus 4. I'll make it so this coefficient here is a 1, so you can easily do synthetic. This one's a little harder, but when you do that division, you get this purple line, and this purple line is the asymptote, and that's what the graph approaches. So I did the same thing. I put a dotted line of red, vertical asymptote. I plotted my intercepts that I found by letting y equal to 0. The y-intercept is also 0, 0. And then I plotted this purple line as the asymptote. And again, that's what the blue line is going to approach eventually when it scrolls that way and when it scrolls that way. Okay? So again, you'd have to plot that, and you want to, the red being the vertical asymptote and the purple being the slant asymptote, you want to use dashed lines for that. And again, I'll make it so the long division or synthetic division isn't as challenging as this particular one. All right, and the last one. So first thing, factor the numerator, factor the denominator, factor a 2 first, then go ahead and double bubble, and then double bubble the bottom, and you get this. And you're like, ooh, look at that, x plus 2 and x plus 2. Anytime you have a factor that will cancel, that's going to create a hole. You still cannot let x equal -2. It's still a domain restriction. You would get 0 over 0, which is nonsense, which means you cannot plug in -2, and that creates the hole. The question is, how do you find that value? We know the hole occurs at an x value of -2 because that's what makes this 0 and this 0. But how do you find the other one? You're like, well, dude, remember, when you effectively cancel that, you get this function. All you got to do is plug in -2 to this function, and it will give you a y value that's associated with that x value. So 2 times -2 plus 3 over -2 plus 1, and you get -2. So that's the location of your hole. And again, I plotted over here in orange. Then I'm going to do the same thing I did on the other ones. The vertical asymptote is when this is equal to 0. Again, you don't have to worry about that guy because that was already the hole. There's not a vertical asymptote at the hole. So we're just worrying about the other one. So there's a vertical asymptote at -1, so I plotted that in red. The horizontal asymptote, since they're tied, it's an x squared over an x squared, and you look at the ratio, since they're tied, you get y equals 2, so put your dotted line there. Then I found the x-intercept was where the numerator is equal to 0. Well, when x is -3, that's 0. And then I plugged in 0 for x. And again, you can plug in 0 for x anywhere. And you can find out the y value is 6, right? You just get 12 over 2, which is 6. Plot those 2 points. So I have my intercepts. I have my hole. I have my vertical asymptote, I have my dotted line, a horizontal asymptote, and then I go yump, yump with my graph. And I know it has to be there because I know it has to go through these points. And on this hole, just make sure you use an open circle. Okay? All of these steps are the same. It doesn't really matter how complicated. So I tried to give you an example. This one had a hole and a horizontal and a vertical. This one had a slant asymptote. This one had 2 vertical asymptotes. This one had 1. This one, and the first one had 2, and it didn't even have any intercepts. So I kind of give you an example of each one of these things, but I would suggest following the same procedure for every single one of them. Factor the numerator and denominator. Decide if there's a hole. If there is a hole, find out its location. Find the vertical asymptotes by looking when the denominator is equal to 0. Find the horizontal asymptote by deciding whether the powers, whether the numerator wins, which means a slant asymptote, they're tied, which means you have to look at the ratio, or the bottom is bigger, and that means it's 0, meaning y equals 0. Then find the x-intercepts by deciding when the numerator is equal to 0, and then find the y-intercept by plugging in 0 for x. At that point, plot your dotted lines with asymptotes, plot your x and y intercepts with and holes with points, and then draw nice smooth curves through them. If you need additional points, like on this one, we didn't have any x-intercepts, we didn't have any y-intercepts, so we weren't really sure what happened in here, so you just have to plot points. The easy points to plot are the ones that are right or left 1. So just go to this asymptote and just go 1 to the right and 1 to the left. Go to this asymptote, 1 to the left and 1 to the right, and all you're doing is taking that x value of 2 and plugging it in here. Just plug it in for x and you're going to get 2. So you know 2 comma 2 exists. Plug in 1 and you get 2. Plug in 4, you get -1. Plug in -1, you get -1. Now you have an XY chart in which you can plot boom, 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 and then you can draw the nice smooth curves. Okay? And that should be it. There were 4 multiple choice questions, and I think I published the key on those. But those shouldn't be too bad. But you should absolutely fully expect at least 5 graphs on the test. No calculator, having to plot all the asymptotes, the intercepts, identify the domain and the range, find the slant asymptotes, identify the holes, all that good stuff.